Hello, friends. Welcome to our channel where we are trying by all means to present lessons in a manner that is user-friendly, in a manner that will make you understand these things without challenges. Okay, so we continue dealing with the calculus, and in this presentation, we are trying to deal with the introductory part to integration. Right? What is the integration? What does it mean when someone says integrate? All right? Now, when I talk about integration, I must be quick to mention that integration is just the process of finding an integral. All right? What do we mean? We are saying it is a process of finding an integral. By that we mean that it is the process of finding the area under the graph. So by integration, you are finding the area under the graph. Alright? In other words, by integration we mean you are finding the antiderivative. By antiderivative again we mean it is the reverse process of differentiation. It is the reverse process of differentiation. If you remember differentiation, you would say, if you have got y is equal to ax the power n, alright, we would say dy dx is equal to nax 1 n minus 1, isn't it? Well, we are subtracting 1 from the power. Okay. But for differentiation, or I mean integration, for integration, instead of subtracting 1 from the power, you'll be adding 1 to the power. Instead of multiplying the power here by the coefficient, we'll be dividing. Alright? So we are saying by integration, we are talking about the area under the graph, or we are trying to get the antiderivative, the reverse process of differentiation. Now, I must be quick to mention that when we are dealing with integration again, there are two things that we deal with. Alright? Or maybe three. We deal with what we call an indefinite integral, definite integral, as well as the area under the graph. Okay, so in this presentation, we want to talk about an indefinite integral. This is an integral without the limit of integration. There is no limit of integration. And because of that, when you are done with the process of integrating, you always insert a capital C, which is called an arbitrary constant, because you may not be in a position to pick or to understand or to tell the kind of a constant that was there as they were differentiating. Alright? Because you have a derivative or a gradient of a function, then you would want to take it back to the original function. So you may not understand the original constant that was there. Hence we fix an arbitrary constant if there are no limits. But of course, we are able to find this. Alright? So I think in the next video, we'll look at how we'll be getting the arbitrary constant. So what we are saying is that when you are differentiating, when you are integrating, right, a function, and that function has no limits of integration, we always insert a C. And it means we are dealing with an indefinite integral because we have no limits. Alright? But what is the rule? What is the basic rule of integration? We are saying if you have a function, this one, alright? You have a function there. Okay, let me erase this. If you have a function, y is equal to axn, alright? How do we integrate this? Alright? We'll put it in this symbol, alright, which is an integral, alright? So, how do we integrate this? With respect, dx, we are saying with respect to x. So, we are going to maintain axn, but add 1 to the power, then you get whatever value of the power is, you put it down, you divide it, alright? It becomes your denominator. Then you add the 1. You see, because here we do not have the limits, here. Alright? Where we have a limit, we do not add the arbitrary constant, and it means we'll have changed now from indefinite integral to definite integral, where we begin to get the actual value. Are we together? Where we begin to get the actual value. Okay, so let's see how we can use this formula, this very friendly formula, to deal with these four examples. Maybe I might just do the first three, then I'll ask you to do that. Or if you will be lucky, I might do all of them. Okay. So now, the first one, we have the integral of 3x to the power 2 with respect to what? So we have been asked to get, or to integrate this. So what we are going to do is, we'll say 3x to the power 2. But now, to this power you add a 1. So you say plus 1 divided by 2 plus 1. The same 2 plus 1. Then you fix an arbitrary constant because we don't have the limits of integration. So this means that our answer will be 3x to the power 3 divided by 3 plus the arbitrary constant. Alright? And what does this mean? 3 and 3 would divide. So you're going to have x to the power 3 plus the arbitrary constant, which is a c. And that's your answer. Alright? If you want to differentiate this, if you want to deal with the differentiation, you would do say 3 by 1, it would be 3x. 3 minus 1, you have got 2. Alright? Now, when you differentiate a constant, you get a 0. Then this becomes your answer, which is this. Alright? So when you integrate the gradient of the function, alright? So when you integrate the gradient of the function, you are going to get the original function of a curve. Alright? You're going to get the original function. This is what you're going to have here. Okay? So now, we are saying, in this case, this one is our answer. Alright? So, by integrating, it means here, we have integrated and we are done there. I hope that is okay. Okay, so let's deal with the second one. So we need to integrate 3x minus 4 with respect to what? X. So now, for this one, I would encourage you that you would write it in such a manner that you have something that you can be able to integrate without challenges. So this is the same as 3x to the power 1 minus 4x to the power 0, everything with respect to what? X, because x to the power 0 is a 1. 1 by 4 to be 4. You have not changed anything. So now we are going to integrate. What are we going to get? We are going to say 3x, there's power 1 plus 1. Everything here you divide by 1 plus 1. Minus 4. X to the power 0 plus 1. You divide everything by 0 plus 1. You add an arbitrary constant. Okay? You add an arbitrary constant. Okay? So this would mean that we have 3x to the power 2 divided by 2. Alright? Minus 4x, because 0 plus 1 is 1, so we can just write that. Divided by 1 plus an arbitrary constant. And now, what is 1 into 4x? You have 4x. So we can get rid of the 1 here. And this becomes, take note, an arbitrary constant. So it's not, so you have something like that. So here we end, and that's our answer. Okay. We can do the third one. Okay, for the third one, we are going to say the integral of x to the power 2 minus 4x. Now, here where there is 4x, I can easily put power 1, alright? Because that is like a dummy number, it has no effect. Plus 5, but I have to introduce an x, so I'll say x to the power 0. By that it means there is still 5 here. Okay, this is what we are going to deal with. Okay, so how do we integrate? We'll say x to the power 2 plus 1. Everything divided by 2 plus 1 minus 4x power 1 plus 1. We divide everything by 1 plus 1 plus 5x 0 plus 1 over, or divided by 0 plus 1 plus an arbitrary constant. Okay? So this is equal to x to the power 3, everything divided by 3, minus 4x to the power 2, everything divided by 2, plus 5x to the power 1, everything divided by 1, plus an arbitrary constant. Right? We can still simplify this as x to the power 3, everything divided by 3, minus 2 into 4 is a 2, x to the power 2, plus 1 in 5x, you have got 5x, plus the arbitrary constant. Why? Because x to the power 1 is x, and that is our answer. Alright? That is the solution. So that's how you integrate these things. Okay? Take note, this is the C, not B. This is the C. Okay, so let's try the fourth one. Okay, so let's try the fourth one. So now, with this one, we are dividing everything by what? By x. So we have x to the power 4 divided by x. We can divide it 10 by 10. Plus 2x to the power 3 divided by x. Minus 3x divided by x. And we are integrating everything with respect to x. Right? Now here, we are just trying to rewrite. We have not started integrating. So x into x to the power 4, you have x to the power 3 plus 2x into the power 2 minus 3x, because this and that will divide. So we need to integrate now everything with respect to x. I hope that is clear, friends. So we need to integrate everything with respect to x. Okay, now here again, when there is 3, you can even introduce x. Alright, take note, we can even introduce x here so that we make our job easy. So this is the same as 3x to the power 0. Because x to the power 0 is 1. But 1 by negative 3, we have negative 3. So now we begin to integrate. So what are we going to have? We'll say x to the power 3 plus 1 divided by 3 plus 1 plus 2x to the power 2 plus 1, everything divided by 2 plus 1, minus 3x 0 plus 1, everything divided by 0 plus 1, plus the arbitrary constant. Okay, I hope it's easy, friends. Okay, so you need to enjoy these things. Yeah. Okay, so we have x to the power 3 plus 1, 4. Here it means we'll bring down a 4 as well. Alright, plus 2. X 2 plus 1, 3. Here everything by 3, right? Minus 3x to the power 1. Everything here over 1 plus our arbitrary constant. But here you're unable to divide or you're unable to pick the common factor, so you can even maintain like that. But now 1 into 3x, it will be 3x. So this one can disappear and the 1 because it has no effect. And this one is our answer. Alright? That one is our answer. So now I'm going to give you an exercise which you can try. Okay? Yeah. Okay, so this one now is your exercise. We are saying integrate this. Alright, now maybe with the last one here, take note. This is my s. So this is s squared minus 2s plus 3. This is not 5. It's not going 5. It is 2s. Here, s squared. Alright, so s squared minus 2s plus 3 with respect to s. This is ds. Okay, which is with respect to s. I hope you have tried my best to break down these concepts, and I'm sure you are able now to integrate a function. That is if at all you are dealing with an indefinite integral. Don't forget to always put an arbitrary constant. Please, if you have liked my presentation, please you can share the link with your friends. If you're a teacher, you can as well share the link with your friends. Those of you that are writing GC exams, this is the right channel for you. Okay, so you can subscribe so that you're able to get videos as long as we upload them. Thank you so much.